Hello everybody, this is a video about comparing and ordering fractions. Okay, but just before we get started, I'd like to do a quick helpful recap of what we did before. This, it's up to you whether you record this, but you do need to be comfortable with what we're doing here, or you're going to have a little bit of difficulty going through our various stages of what we do during this to compare and order fractions. Okay, so just a quick, this is a recap of finding equivalent fractions or lowest terms, okay, which is really doing the same operation. Okay, so our method we've used before is you figure out what you've multiplied 5 by to get 25. So hopefully you are noticing you would multiply by 5. So you do the same thing up here to get 20. Yikes. Once again, excuse my ridiculously awful smartboard writing. It's not so much different than when I do it in class at school, so this should bring back some happy memories. Now, need to do something similar here, but just keep in mind that you can do this in either direction. Okay, so over here we did 5 times 5 equals 25, but we can do it this way too. So 2 times what would equal 8? Okay, so that's times 4. And then we do the same thing over here, which is very exciting. So we do 3 times 4 as well, so we get 12. And then those two fractions are equivalent to each other. Okay, now when we want to express these in lowest terms, again, we're trying to find the lowest number that we can reduce them to, or the biggest number that we can equally divide out of both the top and the bottom. Okay, now remember, you don't have to notice all at once. So there's a few things you might notice you could divide these by. You could divide them by 4. That would be the fastest way. So you can divide a 4 into both the top and the bottom. So if you divide each of them by 4, 12 divided by 4 is 3. And 20 divided by 4 is 5. So you get an answer of 3 over 5. Now, if you didn't notice the 4, you could divide top and bottom by 2, and then divide it by 2 again, and you would still get down to this one. Okay, so take a moment and try this on your own. Pause the video if you need to. Go ahead. Okay, I'll just keep going with the video, though, in case you didn't. For this, again, you can hopefully notice you can divide them both by 3. So divide by 3, yikes, to get 3 over 10. And then there's nothing else other than 1 that you can divide 3 and 10 by, so you know you're done. So each of these is in lowest terms. Okay, on with our comparing and ordering of fractions with a pause to admire my beautiful hair. Okay, this is our learning goal, so we're learning how to compare different types of fractions. All right, and again, put a title and a date on the note that you're making right now. Yes, you need to make a note, but you don't need to write down the learning goal. It's just for reference. Okay, so this is this is not comparing anything yet, but this is a very crucial idea or thing you need to know how to do when you're dealing with fractions, and we will come back to this a few other times throughout this unit. So this is finding a common denominator. So a common denominator means that you are converting both of these fractions to new ones that have the same denominator. Okay, so common just means the same. So the first method for finding that common denominator is you can just multiply the denominators together. So that means your common denominator, which I'm going to call CD for obvious reasons, if you do 3 times 5 would then equal 15. So what you're wanting to do then is to convert each of these fractions into a number with a denominator of 15. Okay? And if you were able to do the review that we did on the first slide, this shouldn't be too tricky, but you just have to then find out what the numerator is for both of these. Okay, so 3 times 5 gets you 15, meaning you would do the same on the top to get 10. 5 times 3 Okay, gets you 15, so we do 3 times 3, which equals 9. Again, we're not multiplying by 3 here because there's a 3 up here. That is just a coincidence. We are multiplying by 3 because that's what you would multiply 5 by to get 15. Okay, now it is not a coincidence that this 3 is the same as that number there and this 5 is the same as that number there. Doing this way, using this method, will always look like that. Okay, but the key point is that you've now converted them into two fractions with the same denominator. Okay, the second way of finding a common denominator, again, we're still finding common denominators, is that you are finding the lowest common multiple of the denominators. Okay, and it is worth mentioning here as well that there are an infinite number of possible common denominators for any pair of fractions. Okay, so you can find as many of them as you like. We only ever need to find one, and usually you want to make it as small as possible so that your fractions are easier to work with. Okay, so using method 1 with this, we could multiply 4 times 6 and get a common denominator of 24, but there is a smaller one. Okay, so there is a lower number, and you may need to go back and review what in the world a lowest common multiple is, because many of you maybe have forgotten since we did that back in September, I think. But you want to find the lowest number that both 4 and 6 can evenly multiply into. Okay, and that number for us in this case is 12. Okay, so hopefully once you see the 12, you can say, oh yeah, so 4 evenly goes into 12, and 6 evenly goes into 12. And again, this is a smaller number than you would find using method 1. And sometimes that's a very desirable thing to do. Okay, so again, just like before, you want to convert them each to a fraction that has that same common denominator, which is 12. So 4 times 3 gets you 12, so you do 3 times 3 to get 9. The fact that these are both 3's is a total coincidence, so don't read too much into that. 6 times 2 to get 12, so you would do 1 times 2, so that means 2 over 12. So now we have equivalent fractions, again with the same denominator. Now you've got two methods to find common denominators. I'm sure you're all very excited about that. Now, when we're finding or comparing numbers, so that's what we're moving along to, so we're comparing numbers. When the denominator is the same, okay, just compare the numerators. Okay, there's not really much to this when we're putting fractions in order, okay, or comparing them to see which is bigger. All right, so hopefully you're well aware that 6 is bigger than 3, so that means we'll put our nice greater than sign here, or is that a less than sign? I guess it doesn't matter. The bigger end, the open end, points to the 6, or the alligator is trying to eat the big number, which is the 6. We can put some nice scary teeth in our alligator mouth. Yes, this is hopefully adding some lightness to a topic that maybe is not the happiest for students. Okay, so ooh, that's scary. So our bigger number is 6. Now the second method, the other way you need to do this when the denominators are not the same, okay, is that you have to find that common denominator that we did before. Okay, so step 1 is create that common denominator, and yes, you should be writing all these down except that learning goal. You can skip that. But that second method here, so you need to create equivalent fractions first. Okay, otherwise you can't, sometimes you'll be able to tell, but usually not. Okay, so all you're doing, so finding the common denominator, so it's 3 and 5 again, and if you remember back from our example way back for method 1 for comparing them, these ones you can just multiply together. They're fairly small, so we'll just use that method 1 that I used, and the common denominator then is 15. So what we're wanting to do again with the common denominators is find an equivalent fraction for both of them with a denominator of 15. So 3 times 5 equals 15, so you want to do 1 times 5. Again, whatever you do to the bottom, you do to the top every single time. Okay, so 5 times 3 gets you 15, so you do 2 times 3, and this one gets you 6. Okay, so then you compare the numerators. So 6 is clearly bigger than 5, so this fraction is bigger than this fraction. Okay, now on this last slide here, what I would like you to do is pause the movie for a moment and figure out which pair, inside each pair, which of the two is largest. Okay, you'll notice that none of the denominators are the same in each of the examples, and in this case I've even got mixed numbers, so you can think for a moment about how you might deal with that. And so pause the movie, try out those examples, and then we'll go through them to make sure you're on the right track. Go. Okay, so I'll come back and get started on these. Now, this is a great example right here of when we would not want to do the method for the common denominator where you just multiply them together. Okay, because 12 times 8 is a big number and you end up doing a lot of silly things with your numerators. There's a lot more possibility for mistake. Okay, so our common denominator in this case, the lowest one you can get is 24, but again 48 would also work, or you could do 8 times 12 and get 96, and that will work. And I think there's a few other ones as well in there. But in our case, 24 is a smaller one. It will prevent having to do some ridiculous math, so we won't do that. So 8 times 3 equals 24, so you do 6 times 3 to get 18. And 12 times 2 equals 24, so you do 8 times 2 to get 16. Very exciting. 18 is bigger than 16, so this one is biggest. Okay, now when you get to mixed fractions, the great part is you can almost completely ignore the whole number. The only exception being that if one of the whole numbers happens to be bigger, then you know right away which one is bigger, and it's whatever one has the biggest whole number. But that's a silly question, so we'll assume that the whole numbers are going to be the same in most cases, so you can basically ignore them. Okay, so I'm going to cross them out just for a second because we don't need to concern ourselves with them at all. Okay, now our common denominator here, if you looked carefully at our numbers, 6 actually goes right into 18. So our common denominator can be 18. Yes, it can work that way, and it's great when it does. Okay, now, so again, we're wanting to convert to things out of 18. And actually, I guess I didn't even need to write that because this is already out of 18, so 13 is still the number. You did 6 times 3 to get 18, so you do 4 times 3 to get 12, so that means this one is bigger. Okay, so the whole numbers really had nothing to do with it. Again, you just have to make sure they're the same first and then ignore them for the rest of the question. Okay, so I hope that made sense to most of you. I hope it was not too silly with my drawings and my ridiculous writing with the Smartboard pen. And please go on to work on the worksheet that I included with this. And again, please feel free to ask any questions that you might have. Thank you very much.